Okay, this is the circuit that I have built. I'm starting with a 12-volt power source, and because I'm a little bit concerned about working with the full power, I'm temporarily reducing it with a 1 kilo ohm resistor, and I imagine that I could add a potentiometer here temporarily to see what voltage works best. At this point, I'm just doing this for safety. This probably should be removed. A 1 microhenry coil. As you can see here, I used a T50-2 toroid wound, I think it was 14 times, whatever it took to make 1 microhenry. It's going to the 2n7000 MOSFET. The source is going straight to ground. The gate is connected through a small value capacitor to the pulse width modulation output pin, and this is biased a little bit above ground. For some reason I was biasing it to about 3 volts, closer to where it should be, and it wasn't working like I thought it did, so I kept bringing it down, and it turns out it was working improperly for a different reason, but it seems to be doing fine even at this lower value, so I ended up not changing it back. One of my questions is whether or not this should be put closer to 3 volts, or if it really matters because the pulse width is more of a square wave, so maybe it's not that of a significant point, and I made that using a simple voltage divider. Also, I'm using a different power source for 5 volts to make this bias than this power supply. This is its own source. I might as well show that. This is the transformer we talked about earlier, and you can see I've got a 5 volt and a 12 volt regulator. This one puts out about half of an amp of current, maximal, and this puts out about 0.2 amps maximal current. So it seems to be, I'd like to use this for the logic and that sort of thing, and devote this guy entirely to the amplifier. This is the actual circuit. It's in a little board. I have an AT-Tiny 44A, and its clock out pin is coming in here, and I'm actually running 2 of these MOSFETs in parallel. Dinner's ready. I'm running 2 of them in parallel, and they're cool to the touch, which is good. Earlier when I was running at the full 12 volts, it was running pretty hot. One of the issues it seemed to be having, although this is great, I mean a good strong signal, even at this lower potential, turn the light off, it's a good, nice signal. However, some of the PWM traces seem to be getting in there. If I zoom out, you see that? These extra spikes, those correspond to the PWM. When PWM is activated, those spikes are visible, and when PWM is gone, those spikes disappear. So this goes back to a previous issue we had, where some of the pulse width modulation signal is actually getting into the clock out, which might make it a little bit more difficult to develop non-noisy signals using the clock out. There we go. Really, really clear now. Turn on the intensity, and hopefully we can start to see. I want to zoom in, but I don't want to lose our source. That's a little bit better. There we go. Now you can see it's very clearly the PWM getting in that clock out. And I'm not sure what's causing that. Right now it's set to make triangle waves, so it's doing PWM from 0 to about 35 on a 255 scale, and it's doing it slowly back and forth. And I mean, you can see very clearly. I'm not yet running the output of the amplifier through a small value capacitor, so perhaps if I run it through the capacitor it could help reduce some of the DC difference, but I don't know if it'll do it completely. So I'm going to zoom in again just so you can see. There is the actual signal. So I don't know what the issue is. So hopefully I can get it. Hopefully I can get it working. And there is the circuit diagram once again.